Tactile technology. And part of our regular Tuesday, Tintri Tuesday, what we're going to do is talk about Shawn at Tintri, a little bit of his background, but also learn a little bit more about the actual sequel release that Tintri have just put out. So let's jump over to Shawn. Hi, Shawn. How are you?
Oh, pretty good, and thank you for having me. I appreciate
Yeah,
it.
there's a little bit of time difference. I'm here at 5 p.m. and you're over there. I believe was it 3 p.m.? No, 11 a.m., isn't
Uh,
it? Because you're
11 a.m. for
Central Time. So tell us a little bit about yourself then, Shawn, your background and how you ended up at Tintri.
sure. So, I'm actually a SQL Server DBA by trade. And so when Tentry is looking for somebody to help them out with this product who understands infrastructure and SQL Server, they were looking for different people, and they had a relationship with me. So Tentry and I have actually presented the last 6 VMworlds on SQL Server topics. So I've known Tentry for a long time. I've known the product line. So when they were trying to find someone with a deep background on SQL Server, I was a natural fit. So I worked Fortune 500 before that. I had an internet startup back in the early 90s. And then, of course, I was a SQL Server DBA. And then I became a consultant. So I worked at House of Brick Technologies. I was the SQL Server practice lead and a SQL Server consultant for them, handling many, many different clients of different ranges and scopes all over the world.
So very deep into the sequel world then by the sound of things. So how long have you been
Yes.
with Tintri now? Is it quite a short period, just part of this new
Yeah.
project?
Correct. So they've been working on the project for quite a while, but they wanted to get it wrapped up and released, and so they brought me on in October of last year. So I'm right around 8 months now, just to come through, help polish it off, and then make sure everything works properly, and then work on discussing how cool it is. And the thing about it is when Tentry actually approached me about the coming over, I'm like, I heard their spiel. I've heard similar spiels, and they go, "That's marketing vaporware. It doesn't work that way." Blah 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 blah. And then they got me in front of the product and says, "Here, go play with it." And then it's like, "Hey, wait a minute, this actually works. This does what it says it does." Wow, this is so. Then I'm like, "Can I? When can I start? When can I start?" I got really really excited. Besides just joining an organization of having a technology, but now it's actually a completely revolutionary technology, and I'm very excited about being here.
Yeah, because I've been involved with Tintri quite some time, so I understood what they were doing around the traditional virtual machine space, with ensuring that each workload had its own isolated quality of service, and it was being delivered, fed and watered the capacity, so it was never be impacting others or being impacted by others, which is a critical thing. But with this new
Yes.
release, we're doing the same thing, but for SQL Server, and also you can actually put a SQL Server on a physical box against this as well using SMB3, I believe. Is that correct?
Correct. Correct, and that's basically what the difference is. I mean, end of the day is, in a VM store in the virtual world, we're only managing virtual machines, obviously. So now we're going to manage databases. We don't care where the database is. We don't care what platform is it, hardware, physical or virtual for a database. It's just a database. So we're going to manage it at the database level. And one of the main concepts here is we're changing the unit of management from a LUN volume to the unit of work. In this case, sometimes it's virtual machine, sometimes it's database, or any other kind of storage construct around any other virtual or any other kind of unit of work later on. So this is a restart for Tentry to some extent because we've changed a lot of code to make it handle things besides virtual machines. But once we have it done once, we can do it for other types of non-traditional objects or objects individually from a storage concept.
Yeah, because I say looking at whether people have worked with databases from a performance perspective, there's been a lot of things like over provisioning of capacity, to ensure you're getting the right level of performance and things. So moving away from this LUN concept or volume concept to looking at a specific database storage and also the individual database, I believe, not just the actual SQL server, is quite a unique way of doing things, isn't it?
Yes, it's fantastic because then again, I can now drill down per database. So all my management and my visibility is per database. So I can see it's also per database file. So I can go see if my logs or my data file. And if I have multiple data files, I can see where the hotspots are. When there's a performance problem, I can identify, where it's at. Because a common scenario, a typical SQL server will have a median number of databases around 12. Sometimes you have a couple hundred. We've seen a few thousand on occasion. Sometimes you only have one or two. But in reality, 10 to 12 is a fairly common number of databases on each individual SQL Server instance. So that's all sits in one data store, typically speaking, or or a LUN. And then, of course, if I happen to be in virtual environment, I'll tend to have 3 to 5 SQL servers on the same LUN. So I have 60 databases in one spot. One bad query from a business analyst who's running a report for some VP who wants to pull data for the past 5 years, whatever, now takes a lot of IO. That is going to hog or use all the resources available, and it's going to impact all other 59 databases on that same LUN. So now with SQL integrated storage, each database has its own IO channel. So those bad queries don't impact anything besides that one database. So the other 59 databases still operate the same way,
Yeah.
which is fantastic. The workload isolation is just amazing.
Yeah, because what we've seen with traditional virtual machines in that is you don't have to worry about loading a new application into a virtual machine. It just works. And having that ability to do it with both physical as well as virtual based SQL servers is a great advantage when you're initially deploying. But I think there's lots of other advantages around protecting the actual data in within the databases as well.
So we do data protection now per database, which is fantastic because if I happen to have databases on that system, I don't care about protection. I'm actually wasting again over subscription of resources. I'm doing protection for things I don't care about. Or if I want to have different policies, so like today, all protection policies are by database instance, for example, on a LUN level. So I have to have I have different servers for different protection policies. So I have a gold, silver, and bronze tier of SQL servers. Now I'm doing it per database. They can all sit in the same server, and I don't have to worry about it. And then also, since I can do the QoS by database, I also don't have to do separation bad to noisy neighbor concepts. A lot of times, there's a few databases out there are extremely chatty. I didn't want to name any names, but there's some of them out there that are just extremely chatty, and most DBAs end up putting them on a separate instance or use things called like resource governor in SQL Server to limit the speed of that bad database. Now, I don't need to worry about that. I can put them in the same place and still share the same compute and memory, and I can just limit the IOs through the VM store process.
So yeah, we're simplifying the infrastructure is one thing. We've just got one now, a data store that we can put all of the database workloads upon it. We're also making sure that we're guaranteeing the performance for each workload and each database, and we can protect it. What about replication? Can we also then do either asynchronous or synchronous replication by the database? Because I know you can do that with the virtual machines.
Correct. So far, we only support asynchronous replication, like replication to multiple endpoints as well. So I can do one-to-many replications. So far, it's only a asynchronous process. We may add synchronous in the future. We're still discussing it in the engineering side to see how it's all going to work and how to make it all be functional.
Okay, and from a recovery perspective, I'm assuming you can recover, different time points on each individual database independently as well.
Correct, and it's basically by what your snapshot schedule is. So as often as you snap is that when you can recover to, and that's per database. Or the best thing is, so say you happen to have 15 databases on that SQL server, a developer gets in and messes one of them up, for whatever reason, bad query updates, overwrite some data, whatever kind of stuff happens, I can just recover that one database quickly to the exact same SQL server under a different name, and then go mine the data that's messed up and go clean it up quickly, instead of having to bring the whole LUN up and represent it. Or the other things, if I use like other third-party tools, I can do that and mount it and open them up at an individual database, but the performance on those is not very good. Does it work? Yes. Is it fast? No. So if I have to go fix a million rows, it might take a lot longer. Versus here, as I tell customers, the decision to use a data recovery process takes longer than the actual recovery process itself. Because you have to have a meeting to discuss how we want to fix this. You're going to spend more time discussing it before you fix it than actually fixing it.
Yeah, and I would assume as well. Then, if you look at the DevOps side of things, rather than having to wait for IT to deploy a new database for you, you can actually effectively clone any databases that are sat on that unit in seconds. I would assume with the way that the cloning works traditionally in a VMware environment. But also, I would have thought you could refresh the data quickly as well.
Exactly. And so for DevOps, a lot of times you'll see customers or development shops, they have a shared sandbox. Because it's so hard to refresh their dev environments, they might have 4 to 6 developers sharing one area. But the problem is one developer wants to make a change, it might impact others. With the cloning process here, every single user can have, our developer can now have their own sandbox because there's no actual space utilized when I create another one until we do data change. The second thing is our cloning process. When we do the snapshot to do that, they are zero stun, meaning there's no impact to production. So in other words, when that snapshot happens, you cannot determine it from side of SQL Server that there was an IO pause. Many other storage vendors will do something similar, but they'll do an IO pause, which causes a production slowdown, which we don't want. So then, of course, now, of course, every developer can have their own sandbox. Also, with the APIs that we present, they can refresh their sandbox when they want to on their schedule, not wait for somebody else to do it, the DBA or the storage admin. So we're moving the task for the work to the person who's consuming the work, not to somebody else. So we're going to simplify the process and make development much faster. And then, of course, with DevOps or CI/CD, we integrate with a full REST API. They can do whatever testing they want to from this process. Meaning, I was talking to a customer, they use Ansible and Jenkins, and they do a lot of regression testing, and they basically want to have a fresh copy every time, because every time you do a test, it changes your data set. And if I stack 1,000 tests, the end data set is different, and we haven't validated things, or sometimes they find problems that their testing causes issues because they're inserting in, trying to insert bad data, because it crash the system. Well, the problem is the next test still has that bad data in it. We don't want that there. So it is, they start back, and they can, with a snapshot process, it's so quick, so fast, they can refresh that database between every test. They want to go through a loop through 1,000 tests. Each snapshot takes 5 seconds. Each test takes 3 seconds. We can chain all together through their CDCI process, or DevOps. So regression testing is much, much faster. Now the development team can be basically, or your infrastructure team can now be delivering innovation to your development team instead of the development team always delivering the innovation. And we can make development faster and basically save a lot of time.
So if we look back at what we've covered so far, so we're simplifying the deployment process, we're simplifying and improving the operational processes. We're also then increasing the rapid development capabilities of our DevOps teams and doing automation, especially around things like cloning and testing, so we can keep refreshing data automatically. So lots of real benefits for an organization to go down this road. So what's been the response from customers? I'm sure you've spoken to a number of people about it and done early testing. So what kind of response are you getting from them?
I mean, everyone gets really excited. The fun part is, was at SQL Pass Summit last year. We actually had a vendor booth back when you could still go to conferences. And it was fun just doing a demo to a potential customer. And they're walking through it, okay, they don't quite understand how it all works. And once they finally grasp it, the light bulb goes on, their eyes get big, and like, wait a minute, this means I can, and you're like, yep, this means I can, and just fill in the blank on so many different things. And it's just, they get so excited, like, when can I have this? And of course, it's before we went GA.
Yeah.
And now that we are GA, I'm calling all those people up saying, hey, we now have this technology. You want to come try it out. And it's just the excitement level of how much time it can save them. One of the things we talk about is, it saves about 95% of the labor you spend on managing storage for SQL Server, which may not be a lot of time overall, but 95% is a massive reduction. So I have to stop thinking about my storage a lot more. I don't have to worry about it. It just works. And that's one of the best advantages is the labor savings and, of course, the speed.
And that's what Tintri brought to the VM world anyway, for the VM side, reducing the amount of management of the storage and just work on managing the virtual machines themselves within the virtual environment. So it's bringing the same benefits to the SQL database side of things. But then looking forward, some of the other things I've seen around what Tintri brings in the traditional VM space is things like diagnosing issues and also looking at analytics for growth and also modeling growth. I believe there's similar capabilities from the database side of things as well.
Exactly. I mean, that's one of the best advantages is, when we have that, it's a DBA, you get that ticket. Database is slow. How do we troubleshoot that? I go look at every metric I have, looks fine. Of course, the ticket's 2 hours old. So now I go back, I don't have any great metrics. I might have some third-party tools, but I don't really know what was going on there. Versus with the VM store, I actually can look back for the past month and go see what that database was going on with it. I can quickly spot, is it a noisy neighbor stomping on it, i.e., which of course we don't have that problem, so those should just go away. So a lot of times those databases are slow are not a database problem. It was something else on these same shared resources that was the problem that made it slow. So those all go away when you're on a VM store. So you get a lot less database slow tickets. But then when I do have one, because they still do happen, they still need to troubleshoot, but I can actually quickly spot where the problem is at. And since we can track per file level access, we can see when it left the OS from as the IO request to the time we received it and the time we returned it. With that, we can do very detailed, very granular latency metrics per database. So now I'm not trying to do a per LUN saying, hey, the disks are fine, the storage processors are fine. I can actually show you where the latency is coming from and which layer of the storage and the network from the time it left your system, which is fantastic. But then also, as you talk about the analytics side, most DBAs do a pretty good job of forecasting their capacity growth. In other words, they were at 4 terabytes last year on total space, and now we knew we grew by 20% every year, kind of stuff. So we can go figure that math out. They don't have any idea on how to do performance growth. Did we drive? We were at 5,000 IOPS last year. We're at 50,000. They don't have an idea in most cases. They don't have how to measure that. There's no easy way to it for them. They just trust these storage people are taking care of it for them. Now with the analytics, we can go train both of those things to figure out when you're going to run out of capacity and when you're going to run out of performance. Because if a database runs 10% more usage in the same amount of time, obviously it uses more IO, more IOPS. Do I still have the capacity to do that? Which is a lot of times those big meetings come up from, when we've run out of performance, we don't know what's going on. It takes forever of database slow tickets to figure out, hey, you've overdriven this data store, this LUN, this whatever. Now we can spot that ahead of time and trend it. And we can look for the past 3 years to make the trends to figure out when that period is going to grow and project 18 months into the future. And some of the other really cool things is, so say you're going to deploy a common application. We use Splunk as a common one, but from a database perspective, we can do the same thing with databases. But it's like for Splunk, say you're a mid-sized organization, you want to deploy Splunk. Well, on VM stores, we already have 500 customers already running Splunk. We'll tell you how much capacity and performance Splunk will use in general based upon that. We don't show which customers are using it, but we say of the 500 customers who are running Splunk, this is the average sizes, and give you an idea of that. Because what happens a lot of times is a new application is purchased by whatever application team, some business unit buys an application. All right, how much we're going to use it for? So let's say we'll use the term on base. On base is a fairly common image management tool. So how much space was my on base going to use? How much capacity and performance, which can be a fair amount. I have no idea. The documentation from OnBase is fantastic, but doesn't give you guidelines on this. Well, if I had 20 other customers with OnBase, I can go show you what those 20 customers are using wise to help you determine how much capacity and performance you're going to need to run this application. Things that are unheard of by any other storage vendor because they don't even know what applications you have and they have no granularity. They can even show you what the LUN change. They can't show you what database changes are or any performance per database.
And one of the other areas that's grown dramatically within Tintri is also, especially if you've got multiple arrays, around giving recommendations for workload movement. Is that also being delivered part of the database piece? So it can give you a recommendation that this particular database should really be on this machine because of performance, because of other metrics that might be required?
That'd be fantastic. However, we had a limitation on that because obviously there's no such thing as storage vMotion or live migration for a database. And it's more of a Microsoft issue and how the files are locked and accessed. In other words, with the VM or Hyper-V, virtual, VMware, whatever, there's a process to move a VM because that's kind of designed around that process. There's no such concept of that. So what it is, we're doing the same concepts. So for now managing VMs and databases all in the same bucket, we can make the recommendations, but the recommendations are always going to be, if we run out of performance or capacity, to move a VM off because it's much easier to move the virtual machine than it is to move the database.
Okay, well, I think it sounds like an excellent release. So it's simplifying the infrastructure, it's ensuring performance, it's allowing better development schedules because of this capability of cloning, but also not taking up space. It's going to make people more space efficient, so because they don't need to over commit,
Provision.
over permission to be able to get the right performance from their databases. So there's a lot of real advantages here. But like I say, one of the key areas that we've just discussed is that diagnostic of issues. And I've always seen Tintri as being a major player in that space, helping organisations understand where the issues are. Any other points before we
Exactly.
finish today that you think that we should bring forward?
Simplicity. Data protection we talked about, replication, or just data protection policies where your snapshots and scheduling and this kind of stuff. I was given a demo of this product to a engineer at Microsoft, DBA, not a storage person whatsoever. I gave him basic control of the mouse, and he could figure out how to protect databases basically in about 2 minutes. Again, if I put someone else in front of any of my vendor, competitors, storage arrays, and say, "Hey, go set up a protection policy for a database," yeah, no DBA can do that. It's so complex. You have to pull the manual out, try to figure out, because then also you got all the different steps. So if I want it, because I'm doing it by LUN, I end up carving things up. So I happen to have, like, again, gold, silver, bronze. These are the ones that have the replication. These are the ones that have snapshot once per hour. These are the ones we do once per every once a day, once every 5 minutes, this kind of stuff. And so I carve up gobs and gobs of different LUNs and then put the databases into each different LUN process to get the same level. Well, that's, again, complex, lots and lots of steps of defining all those things. And then, of course, if I happen to run out of space in one of those, like the whole overcommit process. So each of those LUNs I've carved up, I have to add 30% overhead, just to make sure I don't run out of space on those. Or if I do, then I have to go do gross process. None of that stuff exists on the VM store. It just works. I can set it per database. I can change it per database on the fly whenever I want to. Again, and a Microsoft SQL Server DBA can figure out in minutes how to do their own protection policies, and it makes sense to them. So the simplicity of the operation, makes it much easier. I mean, again, I don't deliver a 1,000-page manual on how to go set up basic things. It's the average startup time for a VM store, basically from the time it arrives to the time you unbox it, rack it, and it's on the network and operational, is about 4 hours, and most of that's basically unboxing and racking. Once the time it's already racked and stacked and cabled, you power it on, you can have databases or VMs on it basically within half an hour to an hour. Try that with any other storage vendor. You buy an array from somebody else, and how fast can you get it up there running?
That's great. So thanks ever so much for your time today, Shawn. I think it's been really informative. It's built on the session we did last week talking about the basic understanding and capability of the release. But like you say, I think that simplicity makes a massive difference, especially around the data protection. What do I want to protect? What policy do I want to apply? Protect. It's so much easier than all the other decisions you have to make to be able to protect a database and a SQL server.
Exactly. And it doesn't. It's just amazing of how much flexibility you have with the system and what we can do with it. And it just the visibility, the amount of time savings of just not managing storage is where this big advantage is. In fact, I was talking to someone earlier today. We did the math on how much time it's actually saving. It's almost like we can make a statement of, yeah, I'm not going to go that far, but it's almost like free, because the amount of the amount of time you spend managing a competitor's array, the amount of labor cost alone will actually pay for your VM store in most cases.
So.
The amount of basically labor savings you're going to have over the life of that array, it's just cheaper to do it on or less expensive to do it on a VM store.
Okay, well, thank you very much for your time today. That's been great, and it'd be great to get you back in the future when we've had a few more customers deploying it and seeing some of the advantage they're getting. Thanks ever so
Sure,
much.
that'd be fantastic.
Bye.
Appreciate it.